Okay, so today we're going to be talking about parallel lines, transversals, and then um, the angles that are formed when you have parallel lines cut by a transversal. Yesterday, or in the previous lesson, we talked about those naming those angles, and so we're going to use those today and talk about some theorems and postulates that go with them. Okay, so we are going to talk about the parallel line postulate. The parallel line postulate states, it's one of the oldest postulates. You can read it over here. It says it was made by Euclid. And if you have a line, L, okay, and you have another point that's not on that line, there's only one line you can draw that will be parallel to that line and through that point. And so it's called the parallel line postulate. Although there are many lines you draw that are parallel to an original line, but if you wanted to also go through a specific point, there is only one line that you can draw. Okay, so going back to what you learned the other day, again, we're going to be talking about definitions, postulates, theorems about these angles that are formed. Okay, so that's our goal today, is to talk about those theorems and postulates. And so on this first one, we just review, all those relationships. So if you've got two lines cut by a transversal, and so in this case, the transversal is going to be the train, like we talked about, that connects both of those original lines. So this is the transversal that connects both of those lines. Okay, my pen's not working again, so I'll just go to the highlighter. All right, here we go. So this is the transversal T. And it connects both these intersections. Okay, this one here, this one right here. Okay, and so the transversal is what does. And so in that group, we have four interior angles. The interior angles are going to be the ones that are going to be between the two original lines. And so these will be the interior angles. And so for the interior angles, we have both same side interior, which would be like 4 and 5. We have alternate interior, which would be like 4 and 6. And so same side versus alternate interior are going to be an important thing. And then we also have, on the exterior ones, we have alternate exterior angles. So like 1 and 7 means alternating sides of that transversal. So 1 and 7, and then 2 and 8. You can look and read, which ones go together. And then the last one that we will talk about would be the corresponding angles. And corresponding means, if you look at the top intersection, the angle number 1 corresponds with angle number 5. They're both in the same relative position, both on the same side of the transversal, as well as the same side of the original line as well. Okay, and so you can name those. But if those original lines are not just original lines, but they are parallel to each other, then not only will they have a special relationship vocabulary-wise, but they will also have a numerical relationship where the two angles will either be congruent or supplementary. And so I think that would be the important thing. So look at this next one. If we have two lines that are parallel to each other and it's cut by a transversal, again, notice this transversal connects both intersections, okay? And so forms all four of those lines, or there are four of those new angles. And so you got these two intersection points right here, but the transversal creates those, okay? But our original lines were parallel. So therefore, not only will there be corresponding angles, but also, because you've got corresponding angles cut by a transversal and the original lines were parallel, not only are they called corresponding, but also they will be congruent. Okay, so here's the corresponding angles postulate. Postulate means you don't have to prove it. Okay, and so the corresponding angles of this set of three lines right here, the corresponding angles will not only be corresponding, but also congruent. Okay, so these two angles will be congruent to each other. These two angles will be congruent to each other. And then the bottom two, like this bottom left, will be congruent to the bottom left here. And then also the bottom right will be congruent to this bottom right one over here. So I meant to change colors for that last dot. But if you have parallel lines that are cut by a transversal, your corresponding angles will not just be corresponding, but they will also be congruent to each other, which is kind of cute. The alternate interior angles, so again, if you start with parallel lines and they're cut by a transversal, your alternate interior angles will not only be named as alternate interior angles, but also they will be considered congruent. Okay, so they will be the same size and shape. So let's mark these here. Okay, so I'm going to color out here. So this alternate interior angle right here will be congruent to this angle right there. Okay, and so this alternate interior angle here will be congruent to that one right there. So that's kind of cute. Okay, they will be congruent to each other. Next one would be, again, if you start the if-then statement, okay, remember that postulates and theorems have an if-then. If you have this, then this is the result. Okay, and so therefore, we've got, if you have, let me see if I can get a new color. If you have alternate exterior angles, okay, formed by two parallel lines cut by a transversal, guess what? Those alternate exterior angles will be congruent. So corresponding angles are congruent, alternate interior angles are congruent, and then also, so let's mark them. So this alternate exterior angle will be congruent to this one here, and then this alternate exterior angle will be congruent to this one over there. Okay, so very nice. Let's try to find even a better color. Let's go with, we'll go with blue. Okay, same side interior angles. Now this is a different one. Okay, and I would say this because you guys can see it as well. Okay, can you see logically and wisely that, I mean, look, these alternate interior angles, they're going to be congruent to each other. You can tell. Look at those two blue ones. Do they not look acute? Okay. And look at the red ones. Do they not look obtuse? So if you're starting with parallel lines, you can tell visually that it makes sense logically that the alternating sides of this transversal angles will be congruent to each other. Okay. All four will not be congruent to each other in this case because some are acute and some are obtuse, but you can tell visually that those will match up. Also up here for the corresponding, can you tell visually that, hey, guess what? Yes, of course, if these lines are parallel, these two angles have to be congruent to each other. They just look like they are. And again, we're not saying we're going by looks, but we're saying there's a logical assent to the visual portrayal of this picture to say, yes, that does make sense that those two will match. And the same thing is that these guys also will have to be congruent to each other as well. And so I think I want you guys to say, yes, we know it, but also we can see it as well. There's a deeper understanding if you can do both understand as well as see it visually. Okay, and so if you have same side interior angles, I want you to look at this, okay, and think logically, okay? Do you think that these two angles right here will be congruent to each other? Okay, let's zoom in a little bit and say, do they look like they're congruent to each other? And the answer is no. Look, one's obtuse and one's acute. So in this case, okay, I'm not telling you just as I go with your gut, but you can tell they aren't going to be congruent to each other. Instead, same side interior angles are going to be supplementary. They're going to make 180 degrees when you add them together. And so I should add another arc here to be like, yeah, they're not congruent to each other. However, their sum equals 180. And then the same over here, that the sum of this angle plus this one right here will also equal 180 degrees. So same side interior angles will be supplementary, okay? And remember, if we're saying, if we're doing a proof, we're like, oh yeah, the theorem says that they're supplementary. And if I want to go one step further, we could say that means that they make 180 degrees. Why? The reason you would say is definition of supplementary. So if when we're doing a proof, we say, okay, these two angles are same side interior, therefore they are going to be supplementary based on the interior angles, alternate interior or same side interior angles theorem. And if your next step says, therefore, is the left side, you say those two angles at angle 1 and 2 add up to be 180 degrees. Why? Definition of supplementary. So we're saying making statements that are going to be true on the left side and we're saying why on the right. Okay. Okay. The last theorem that we're going to talk about today. Okay. So the perpendicular transversal converse theorem. Okay. So the perpendicular transversal theorem and the converse, again, they're going to be the ifs and the thens are switched. Okay. So the converse we're going to focus on today. If two coplanar lines are perpendicular to the same line, then the original lines are going to be parallel to each other. Okay. If you said it the opposite way and just said, what's the perpendicular transversal theorem, you'd say, if two lines are, let me read it for you. If a line is perpendicular to one of the two parallel lines, then it's perpendicular to the other one. So we could work it either way, but and so the original one, the perpendicular transversal theorem, is the one that I have written right here. If you've got A and B are parallel and line B is perpendicular to T, then the other line also has to be perpendicular to line T. That's going to be the original perpendicular transversal theorem. The converse goes the other way, okay? If two lines are perpendicular to the transversal, then the two lines originally are going to be parallel to each other. So we can keep that in mind, that those are options as we're writing our proofs. It's not very common that we use these, but we're going to put that out here. One thing that we have learned before is the vertical angles theorem, that if you have a vertical angle, pair of vertical angles, they will be congruent, and also the linear pair theorem. If you have a pair of linear pair angles, they will be supplementary. And then remember, by the definition of supplementary, we're allowed to say those two angles have to be 180 by the definition of supplementary. So those are going to be good theorems that we're going to be working with today. Mostly today, our work is numerical, which is going to be nice. Okay, and so if you read this first problem, it says that a carpenter is trying to do woodwork, and they want these two pieces of wood to be parallel to each other. Okay, and so the thing is, if you want those to be parallel, what do these two angles have to be? Okay, that's what they're looking to say. We don't need them to be congruent to each other, but we need them to be supplementary, because remember, they're same side interior angles. So if we can do the math to make it, I'm not sure why he's doing an algebraic equation to figure out the angle instead of just measuring it. However, this isn't our math problem today. And we're going to say, if I would like them to be supplementary, because they're same side interior, then I need to have the two angles add up to 180 degrees. And so if we find the sum of the angles algebraically and solve it by subtracting 30 from both sides, you get 10x equals 150. And therefore x is equal to 15. And we could measure, okay, what does that mean each angle would be? And you could plug the x back in to find the measure of each angle. So the theorem of postulate is the same side interior theorem, okay? And so if we want to say the whole thing, same side interior angles theorem. There you go. And so the next part says, can you tell the theorem that would state each one of these as to why it would be true? Okay, so here we go. Why would angle 4 and angle 5 be congruent to each other? Okay, that would be alternate interior angles theorem. Okay, alternate interior angle theorem. And I'm using a highlighter, so I'll try to move to a pen. And I'm writing with my finger because my pen doesn't work. So angle 2 and 7, why would they be congruent? 2 and 7 would be congruent by alternate exterior angles theorem. Okay, how about 3 and 7? Why would they be congruent to each other? Well, 3 and 7 would be congruent by the corresponding angles theorem. And that's actually a postulate. Okay, while we're here, why would 2 and 3 be congruent to each other? That would be the vertical angles theorem, right? And so, again, all those theorems are still true. We're just practicing our new ones as well. Why would 3 and 5 be supplementary? That'd be same side interior angles theorem. Okay, so just working through. So looking at the upper diagram, if you say measure of angle 2 is that 2x or 5x plus 20, okay, and measure of angle 7 is 7x plus 8, and then also if x equals 6, okay, the question is, would P and R be parallel to each other? And so this is interesting. They're not just saying, hey, use the picture, use your knowledge of the theorems and solve the equation. They're saying, hey, if those two angles are equal to this algebraic expression, and then also the measure of angle 6, or x is 6, what do we know? Okay. And so what we can do is we can plug in the value of x equals 6 into this. We're like, okay, well, that would mean that the measure of angle 2 would equal 6 times 5 is 30 plus 20 is going to be 50 degrees. And if you plug in 6 here, that's going to be 42 plus 8. 42 plus 8, that's also 50 degrees. Okay, so what they're telling us is, if we know that the measure of angle 2 equals 50 degrees, and we know that the measure of angle 7 is also equal to 50 degrees, what do we know? Okay, well then we know that P and R have to be parallel. Why? Because of the alternate exterior angles theorem. And technically, this would be the converse, wouldn't it? Why? Because if you know the angle sizes, then we can work backwards and say, therefore, the lines have to be parallel to each other. Okay. Normally you say if they're parallel lines, well, then that means that the angles are congruent. But if you are working backwards and say, I know the angles are congruent, then what do I know? Well, then you know that the lines are parallel by the converse of the alternate exterior angles theorem. So we will be doing both of these. And I want you to start thinking about in your brain to be, is this something we're saying if they're parallel and they're related, then they're going to be congruent? Or are we saying, hey, that we know that we're congruent, therefore we know that they're going to be parallel? So both of those are valid uses of these theorems and their converses. Okay, the next one says, if the measure of angle 3 is equal to 4x plus 7, and the measure of angle 6 is going to be 5x minus 13, find x. Well, these are going to be alternate interior angles. And this will be the theorem because we know that they're parallel because of the little arrowheads here. Okay, so we know they're parallel. And then if they're alternate interior angles, we know that means they're going to be congruent. So we can set them equal to each other and solve the resulting equation. Okay, here we go. So if you minus x from both sides, you're going to get 7 is equal to x minus 13. Add 13 to both sides, you're going to get x equals 20. And that's all they want. We could go back and be like, oh, then that means the angle is going to be, 27 degrees. And you could plug in x equals 20 into both things and make sure that they actually are congruent. That's a good check. And sometimes I will ask you to find the measure of each angle as well. Okay, if the measure of angle 8 is going to be 68 degrees, okay, right here, and the measure of angle 3 is going to be 3y minus 2, what can we do? Well, those are not related in any special way. And so that's when you've got to think, well, what else do we know? What can we assume if we know this is the case? Well, we know things are parallel, so we know special things are going on. And there's a couple ways you could approach this. Okay, my brain says this. If you know that 3 is a certain thing and 8 is another certain thing, okay, what else can we know? Well, my brain says, well, look at 3 and 7. Okay, 7 is close to 8, and so they're kind of special. But 3 and 7 are going to be corresponding with each other. So you know those two angles will be congruent to each other. So 3 and 7 are congruent by corresponding. So I would say we know that corresponding will help us move in one direction. Okay, the second thing we know is that, okay, so angle 3 and 7 are corresponding. What about 7 and 8? Angle 7 and 8 are a linear pair. And so we know that they are supplementary. Okay, so I'm using two facts, the given, and then two different theorems, the corresponding angles postulate, and then the linear pair theorem to say, well, we know that we can walk according to these situations and say, okay, that means that 68, which is 8, has to plus the measure of angle 7, who is going to be the measure of angle 3, which is 3y minus 2. Don't know why I put two plus signs there. I'll erase one of them. Okay. So if you add 68 plus 3y minus 2, you're going to get 180 degrees. Why? Because of the givens, and then because of corresponding angles of 3 and 7, and then because of a linear pair that 3 and 8 make to be 180 degrees. And so then we're going to combine 68 with 2 at 66. We're going to minus 66 from both sides. You get 3y is equal to 114. divide both sides by 3, and then y is going to be 38. And we could go back and find the measure of each angle, but they don't ask us to do that. So sometimes you have to kind of stack up these theorems and postulates to say, what do I know? And here they give us 3 angles. And so the question is, which 2 are we going to use together to help us to find our answer? And we may or may not use only principles from this lesson. We may use prior principles. And so when I look at this, I do see alternate exterior angles of parallel lines. But the problem is that on this side here and this side over here, okay, that they're going to be congruent, but one has an X and one has a Y. So I'm not going to put an X and Y together in an equation unless I need to, okay? We'd have to literally solve a system of equations, and if I can go another way, I will. So then I say, well, what if we put this angle together with this angle here? What do we know about those? Well, we know that they form a linear pair. Okay, and so if you do 40 degrees plus 5x, you're going to get 180 degrees. And so minus 40 from both sides, you get 5x equals 140. Divide both sides by 5, and you're going to get x equals 28. So the thing is, once you have found one variable, sometimes you're done, and sometimes you are saying, okay, well, I'm going to use that numerical value to help me find the rest of this answer. Okay, so that means that 5 times 28 is going to give us 140 degrees. So that means this angle really is 140 degrees. And now we know we can use the alternate exterior angles. Okay, so alternate exterior. And there's a couple other ways to think about this. If you're like, hey, I see a different way. The truth is there's a lot of relationships numerically when you have parallel lines cut by a transversal. So if you see a slightly different method, I bet you're right. If you're getting the same answer, you're really on a good track. This is just what I chose to do. So alternate exterior angles are congruent. So we're going to do 3y minus 1 is equal to 140. If I add 1 to both sides, you get 3y is equal to 140. Divide both sides by 3, 141, sorry. Divide both sides by 3, and you get y is equal to 147, or is equal to 47. So this is 47, this is 28. We wouldn't put degrees on them because they're really not a degree, okay? So I'm sorry, I labeled that one there. They're the values of x and y. They're not actually the measure of a degree. Once we plug it in, we're like, oh yeah, this one's 140 degrees, and you could plug in the other one and figure out what the other angle is as well. It'd be 140. Okay, next thing would be, again, using these theorems and postulates, can you find the measure of x and y? And which ones would you use? Again, we don't want to put both x and y in the same equation if possible. I see a linear pair going on, but if you did this linear pair right here, you would notice that they would have x and y. Okay, I see same side interior on the right side of this transversal over here. I don't want to use that either because it would have, you could add them up to make 180. It's not going to help us very well either. So if we could write an equation that just has x or y, we are going to be happy. And so let's look and see if we could do, let's see, how about alternate interior angles here? Okay. If we did 5x minus 7 equals 3x plus 17, we would be ready to go. So this would be alternate interior angles. So you say 5x minus, and alternate interior angles are congruent to each other. So that would be 5x minus 7 equals 3x plus 17. Subtract 3x from both sides, you get 2x. And then I'm going to add 7 to both sides. You're going to get 24. So x is equal to 12. Okay. And then the question is, do we need to use this to help us to find the measure of y? And the answer is yes, we do. Okay. There's a couple ways to do this. I'm going to plug it into the angle we solved. I'm going to say, okay, 5 times 12 is going to be 60. And I'm going to minus 7 from that. So this will be 53 degrees. If we check it by plugging it in this bottom angle here, 3 times 12 is 36. If you take 36 and you add 17 to it, you're going to get 53 as well. Okay, so it does check. So this angle up here will be 53, and this angle down here will be 53. Well, the thing is that we've got to find the measure of y. And so to find the measure of angle y, that's in this angle right here, I'm going to do a linear pair theorem and say 5x minus 7. Oh, wait, we know that's going to be 53 degrees. And then we're going to add that to 4y plus 3. We're going to say their sum equals 180 because they're a linear pair. And then that's 56. When you add 53 plus 3, we're going to minus 56 from both sides. You're going to get 4y is equal to, oh, I see what I did. Okay, 124. And then divide both sides by 4, and you get y is 31. Okay, so we could find the measure of the angle by doing 4 times y and adding 3 and get the answer. So we're using these theorems and postulates and also the converses. Okay, if you know two angles are congruent, you can say, well, then we know that the lines are parallel as well. But we're going to be hinting in that today. Well, thank you so much. Have a good day.